Hi everyone. Today we will see how to design a square patch antenna. You may have seen most of the videos on rectangular patch antenna. So today we will see that what are the result of the square patch antenna. Before coming to that, we must know what is antenna. Antenna is a device that transmit or receive electromagnetic waves. So before designing anything, any kind of specific kind of antennas, it is better to read its background, some kind of research paper, so it will help you out. What are the applications of the antennas? Antennas has a lot of applications, like in wireless communications, in satellite communications, and radars. So there are a lot of applications of the antennas. So as I talk about the that we must start our journey with the one of the paper. So here is a microstrip antenna. So you have seen such kind of diagram that describes the patch antenna basically. It has a dielectric substrate. It is a main important while you design antenna. It is very important to choose a correct dielectric substrate. There is another plate that is known as below the substrate, that is ground plate, and there is a small part of that is patch antenna. It has a specific height and a width. So these heights, width, lengths has effect on its different kind of factors, that is S parameters, gain, and other kind of parameters. So you have seen that there are different kinds of patch antennas, square, rectangular, dipole. So you can choose according to your desired results. Today we will start with square antenna. Basically, why I choose is that it is smaller in size, it has equal length and width, and the other thing is that I have to achieve a gain of more than 3 dBs. So we will see what we will achieve the results. So here is another thing, that feed line technique. These are things that we will use. We will talk in other later on this part, that what is feed line, how we give feed line. So it is important to feed line to connect. So now now you can see that it has a pattern, that how electric field lines works across the patch. So in this way, you will see. Now I think we should start. So first off, what you have to do is that uh, you have to choose a substrate. I will start with the FR4. It is most of the common type of substrate used in mobile applications. So I am going to design a. You have to select a cube, draw here. After drawing that, you have to click on the box, give it a name substrate. Now you have seen that here is a box of material. Go on edit and search FR4. Now you have seen that it has a relative permittivity value of 4.4. So I say okay. Now you have seen that it has a color of this kind. If I want to give any other kind of color to it, we can give it. Like I have want to give that kind of color, such kind of color. So click OK. Now you can see that it will become of that color. Now I have to give it a parameter, that is what are its dimensions. So I want to give it dimensions of 60 and 62. That has some other effect, that we will start with this position. It has substrate and has nothing. You have just have to calculate the height of and width and length of the patch. So you can give it substrate any kind of height. Even if you want to a good result, you can change these parameters. And I had already told we will give it a height of 1.6. Now we want it at the middle of axis, so we will divide it by 2 minus 62 divided by 2. Now you have to click on fit all. It will become like this way. Now what we have to do, we have to click on orient box, click on the bottom, and this is the ground plane. Basically, that is the back bottom of the substrate. Here we have to give a ground plane. Click on it, rectangle, and do the same way of the same height. Now click on it, give it a name of ground. I want to give it a orange color so it will look like similar to copper type. Mm, Now it has this good results. Now you see that it's gonna change, and now I will click on the orient, and now I have to design a patch on it. So for the patch, I have calculated some of the values like these are the patch values. Patch length is 29.4 and patch width is 38. Uh, how I calculated this kind of thing, there are a lot of online calculators. You can get from it. Like I want to click on it, calculator for patch antenna. Click on the first one. Now you see that it has write that dielectric constant. Here you have to write that my dielectric constant value is 4.4 and dielectric height is 1.6. But I have choose the unit of millimeter, so I will select millimeter. Now what is the operating frequency? The antenna will operate at 4.4 gigahertz. Now I will calculate. So here you can see that here is the width and length that I mentioned you here. And if you want to use it by formula, you can put in this formula. These two formulas are very helpful. Now come to that slide. These are the calculated values, but we use 28.8. Why we use 28.8? Because we already talked we are going to design a square patch antenna. For the square patch antenna, width and length is same. So here I am going to design patch on it. Give it a name of patch. Its color same gold. Now I have to give it it is same, but uh, here I am going to change it height because I already give it a substrate a height of 1.6, so it will be on the top of it. Here I said I have given a 28.8, 28.8. Now I will give 28.8 divided by 2, 28.8 divided by 2. Now you see that the patch is on the mid of it. Now I have given it a transfer line. Transformer line is that strip. There are two ways. Either you have to put a cut, and then there is a transformer line. So I will go with the transformer line. Here is the mid of it. And what was the height? Let me check it again. 14. If we will use it 15. Let me make a height of transformer line. So what was the height? 15. It was on the negative side, so we will give it negative 15. And the width, here we have seen that the width is 0.6. So the feed line, now we have to connect, select patch, transformer line, and go on operations and unite. Now they are one unit. Now we will design the other part, that is feed width. So now I have to move it at the mid. So you have to select operation, move, and at the mid of it. Now it is at the mid. Now unite this whole part with it by control click. You can unite both the parts. Now it is patch antenna. Now we have to give it a field that will be from the y-axis. So from here, we'll click here and click on visibility. We'll go XY XZ plane and give a feed of. Give it the same color. Give it a feed. After giving it that, we have to click on the feed, assign excitation, click on the port, and model lumped. Go next. And here is the integration line. There is no integration line, so we have to give it an integration line. For that, we have to go in this axis and front side of the. Now it is defined. Click on next. So now the next thing is that we have to give ground and a patch. Where is patch? The patch and ground. Assign them a boundary. Perfect electric. Click OK. And there are few steps left. Create open region. So it will ask me about what is operating frequency. So we give it as a 2.4 gigahertz. Click OK, and that is a radiation box. Now it's seeing. You can see this box. Here are some. If you want to change its dimensions, you can change from here. So after that, you have to click on the analyze. Click on the advanced. It will ask you about frequency, so we will give it a 2.4 gigahertz. Click on next. It will ask you about the linear count. What will be the static frequency? We will start from 1 and end it at 4. and it will ask you about how much point you need. So if we can see how much it will give such kind of differences. So if we give it a point of 201, now we can preview. Now it has 201 points. Click OK. Now click on simulation. Here's a validate. Before analyze all, you have to validate that you have done all the steps. So it means that I have done all the steps. Now click analyze all. It will take, now it will ask me about to save the project. I am assigning, saving it as patch antenna. Now it will run. It will take a few minutes. Now you have seen that it run all the results. So we click on create model, rectangular plot, and we will see the S parameters. So it is S11 and in dBs. Create a new report. Now you can see the results. For the good results, it must be below the -10. So now you can see are the results. For checking at which you can see it is giving that to add marker. Click on it. Now you can see that it is 2.38. So it is best at this point. Now if you have to check the bandwidth, click on -10 from this point to this point. And minus this, you can calculate by calculating if you want to calculate a bandwidth. You can see that 2.4056 minus 2.55. So you can get the bandwidth. Okay. So that was the S parameters. Now if you want to see again, click on the results and go to create far field report and a 3D power plot. Here is the option of gain, and gain must be in dB. So click on the dB and create a new report. Now you have seen that our aim was to get a result of 3 dBs. So it is nearly 2.95. So it means that it needs a little bit improvement. So after little bit improvement, we will achieve our gain. So it is a very good gain. Now you can see how it is. So So another thing is that field overlay. For the field overlay, another thing is that you can also, if you uh, want to click on some part of that if you want to click on the uh, your antennas, you can't click. It will click already on radio frequency. So for that, you have to click on the hide that selected part. Now you can click on your part, any part of your antenna. So I will click on the top of this and click field overview. I want to plot field electric field. So I will go with vector E. It is at frequency this and it has a phase of this. I will click on yes. Now can see that it gave me a E field picture of it. If I want to animate it, click on it and click on the animate starting point and ending point. So now it will animate like this way. So, our aim is completed. Using these kind of techniques, you can achieve your any kind of gain by increasing sizes. So that was about the square patch antenna. If you create here a rectangle, so it will give a different results. It will may give a improved result, but it may not be applicable on some of the applications. So that was of the very small size antenna and with a good results. Thank you.